So we now move to the module 8, which is on metadata. And this particular module will be covered in 3 lectures. So the first lecture is on role of metadata. The second lecture would be on the types of metadata that we collect, and the third lecture will be on design and implementation of metadata solutions. So in today's lecture, I'm going to talk about the basics of metadata, and also about its role in data warehousing, and especially in the from the point of view of analyst, right? And also how it helps in different kinds of performance enhancing techniques. Like if you recall, we talked about aggregate navigation and aggregates as a query performance enhancing technique. So there we use metadata in a big way, and also in metalized views we use it in a big way. And there is metadata corresponding to partitioning and bitmap indexes and everything else that we do in a data warehouse. So it plays a very, very significant role, an active role in a data warehousing environment as compared to the OLTP systems. So let me begin today's lecture. And most of this the material in this presentation has been taken and adapted from W.H. Inman's article on metadata, which was published in 2000. So you can refer to that for more details. So the topics for today are metadata, the main components of metadata, and its role in data warehousing. So let me begin by giving you some idea about metadata. As you know, metadata is nothing but data, and it's a very common practice even in operational systems to capture a lot of metadata about anything that is happening on the database, right? But how we use it, there is not much, say, from an end user's perspective. So there is not much that end user does with the metadata. But in a data warehousing environment, this concept changes totally, and a lot of very important things are captured in the metadata which are used by the end users. So the first image most people have of the data warehouse is a large collection of historical integrated data. While that image is correct in many regards, there is one very important element of the data warehouse that is vital, and that is metadata. And metadata, as we know, is data about data, and it's not a new concept and has been around for a very long time. And there have been programs and the data on which these programs operate. So this kind of information has been captured in the form of metadata, and they've been around for as long as there have been programs. So this is how it is seen. So you have some data, and metadata is some data that you capture about the data, and you keep it in what is called as metadata. And this is not a new concept, as we just discussed. So while metadata is not new, its role in data warehouse is certainly new. And metadata has been continuously ignored in conventional IT systems, and ignoring it in the data warehouse environment is to defeat the very purpose of data warehouse, so as we'll see. And metadata assumes an important role in a data warehouse, and its importance could be attributed to its differences from operational systems. So let us see each one of them. So the community served and the importance to that community are the primary reasons why metadata is so important in the data warehouse environment. IT professional is the primary community involved in operational development and maintenance, and they are highly computer literate and are able to find their way around the systems that they work with. Whereas in a data warehouse environment, or a data warehouse serves the DSS analysts community. So there is a stark difference between the computer literacy of DSS analysts and that of IT professionals. And these DSS, or decision support system analysts, as we call them, they are not as computer savvy or computer literate as IT professionals, and they need help in navigating the system. And the second reason for the importance of metadata in a data warehouse is that DSS analyst needs to know, in order to do his or her job, is what data is available and where it is in the data warehouse. So that's very important. So when the DSS analyst receives an assignment, the first thing the DSS analyst needs to know is what data is there and what data there is that might be useful in or that might be required for the assignment. And for this, metadata for the data warehouse is vital to the preparatory work done by the analyst. So the information technology professionals has been doing his or her job for many years while treating metadata passively. So they have never, as I told you in the beginning also, so in the conventional systems, so metadata plays a very, very passive role, or we can say it is inactive. So let us look at a few things in a data warehouse that requires metadata. So basic part of the data warehouse environment is that of mapping from the operational environment into the data warehouse environment. So it could involve mapping from one attribute to another, conversions, then changes in naming conventions, changes in physical characteristics of the data, filtering of data, etc. And there are so many other things. So all this would require some kind of metadata. Now, to motivate this discussion on the importance of metadata, so let us look at a real-life scenario where the vice president of marketing asked for a new report from one of the data analysts. And after looking at the report that was presented to him, the vice president proclaims that the report to be fiction, that he is not convinced that this report is correct. So the credibility of the data analyst who prepared the report goes down until he or she can prove that the data in the report is valid. So first thing is that the DSS analyst can look is that whether the data that has been taken from the data warehouse and put in the report is correct or not. If it is properly reported, so then the report, if it is not properly reported, then the reports are adjusted accordingly. But if the reports have been made properly from the data warehouse, that is, there is no kind of error while putting the data from the data warehouse to the report, the DSS analyst is in the position of having to go back to the operational source to salvage credibility. So he can actually go back to see what could be the source of data, and at this point, if the mapping data has been carefully stored, then the DSS analyst can quickly and gracefully go back to the operational source. But if the mapping has not been stored or has not been stored properly, then the DSS analyst has a difficult time defending his or her conclusions to the management. So the metadata is a natural place for storing of mapping information, like how the data from the operational system has been mapped to the warehouse. And this is how it looks like. So these are operational systems and the metadata. So all the mappings are captured in the metadata. So the second aspect is managing data over time. So as you know that data warehouses contain historical data, and the lifespan of data in a data warehouse is much longer than the lifespan of data in operational systems. So 5 to 10 years is considered normal in a data warehouse, and say a few weeks to 3 months in operational systems. So the storage of multiple data structures for the data warehouse is contrasted with the storage of a single data structure as found in operational environment. So this is a major deviation from the operational system. And one of the fundamental concepts of data management in operational environment is that there is only one correct definition of data. Whereas in a data warehouse environment, this does not hold. So this assumption is almost like opposite, or 180 degrees the opposite of the data found in data warehouse. And managing data over a long spectrum of time is a necessity. Long spectrum of time is another reason why metadata is in the warehouse is so important. So let us look at how this looks like. So this is the operational environment on the left hand side here, and this is the data warehouse environment on the right. So there is a single data structure and content, and here in a data warehouse environment, so there are multiple data structures, and all these data structures are captured in the metadata. So operational processing assumes that there is only a single correct definition of data, whereas data warehouse processing assumes that over a long period of time there are multiple versions of the structure and content of the data, right? So these the numbers here indicate the year numbers, right? So the multiple versions of the structure and content of data are there. Then we have the versioning of data. Because the data warehouse must be managed over a long spectrum of time in a data warehouse, so the data and the associated metadata must also be versioned. So version data is data that allows changes to be continuously tracked over a period of time. So you have seen slowly changing dimensions and other related concepts earlier in the course. So versioning is important, and versioning of the data is important, and similarly versioning of the metadata is also important, and this is how it is typically done. So this is versioning of the data. So this is on the left is the today's data structure, this is the current, and then we also keep the history of data structures, and you can see the effective from and effective to dates are mentioned, are specified in both the cases, in all the cases, and sometimes we don't specify the end dates or what is called as effective to date, and that can be inferred. So effective to date is kind of optional, and that can be inferred from the the next metadata information, right? So versioning of metadata is done, so in different forms, so we'll talk about that. So in this figure it is seen that both the current status of a structure can be found, and the history of changes to that structure can likewise be found. So this tracking is a necessary feature of all types of metadata in the data warehouse, metadata. And one of the characteristics of versioning is that the data trail be continuous and non-overlapping. So we always make sure that it is not overlapping, because if it is overlapping, then there will be confusions. So in other words, it is important that for any moment in the past there will be one and only one value of state or status of metadata. So this overlapping business does takes care, a non-overlapping nature takes care of that. And effective from and effective to dates on metadata components are placed, so for clarity. And so suppose I want to retrieve a particular metadata corresponding to a particular date, I can do that without any problem. So this how this can be used. So when the DSS analyst wants to interrogate a calculation or report made in the past, that the versioning allows the DSS analyst to understand what data was there and where it came from as it entered the data warehouse. So without versioning, the only meaningful data a data warehouse has is data written for and managed under the most current definition of structure of data. So we know that in data warehouses we deal with historic data. So without versioning, this is not going to work. So now I'm going to talk about basic, so the components of metadata. So there are three kinds. So one is the basic components, and then there are history tracking, then there are miscellaneous. So I'm going to talk about all of them. So the basic components of a data warehouse metadata store include the tables that are contained in the data warehouse, the keys of those tables, and the attributes. So this is, if you see, this is not different from the one that we collect for operational systems. So this is what is done. So the tables, keys, and the attributes all are kept here. Then the second metadata component is that of mapping. So mapping, as I told you, is an important aspect. So one of the most important components of data warehouse metadata is the mapping part. So identifying of source fields, simple attributes to attribute mapping, attribute conversions, physical characteristic conversions, encoding, reference table conversions, naming changes, key changes, defaults, logic to choose from multiple sources. That means if data is available in multiple sources, so what kind of logic you can use, and any algorithmic changes, and the list is endless. So like all other data warehouse metadata, these components should be versions. In fact, the entire metadata should be versioned. And this is what is the mapping part. So this I've talked about earlier also. So from different operational systems, different applications that comprise the operational system or the environment, you do a mapping, and then this mapping, when you do the mapping, all that is collected in the metadata, and the data goes to the data warehouse. Then the second is about history, to extract history as we call it. So the actual history of extracts and transformations of data coming from the operational environment and heading for the data warehouse is another component that belongs to the data warehouse metadata. It tells the DSS analyst when the data entered the data warehouse. And DSS analyst has many uses for this type of information. So information like when was the last time the data warehouse was refreshed, if processing and the assertions analysis have changed over time, whether the results obtained for one analysis are different from the results obtained by an earlier analysis because of a change in the assertions or a change in the data. So all these things he can analyze and he can track using extract history. So again, you extract history and record metadata for all the things that you do. And then we come to miscellaneous. So here it is about alias. So if you remember, so I have it in the next slide. So alias, then you have we talk about volumetric information, status, and aging and purging criteria. So let me give you some details about each one of them. So alias, recall role-playing dimensions, where we created multiple aliases for the same dimension that appeared many times in the fact table. So that's how it can be used, and there are many other simplified names that the data warehousing administrator can give to tables and any other database objects that are there. Status, that's the next part in this. So in some cases a table is undergoing design. In other cases the table is inactive or may contain misleading data, right? And so this status can help you solve all these problems. So if you are not sure that the data that is there in a particular table is up to date or it is correct, right? So you can use the status to mark it. Then we have volumetric information. So the number of rows currently in the table, the growth rate of the table, the statistical profile of the table, like how often it has been used, and other usage characteristics of the data, the indexing that is available, and its structure. So all this information is kept under the volumetric head. And then finally we have aging and purging criteria. So definition of the life cycle of our data warehouse data. So here what we keep is, like, we define the life cycle of data in a data warehouse, right? And without that, so when the data has aged or is required to be purged out of the system, so I think I mentioned this earlier also. So there is typically a sliding window protocol, so which moves ahead in time, if which captures the latest information and purges the oldest information. So I'll try to show it to you here. So you have a sliding window. So suppose I have data from 1999, 2000, 2001. So now I need to bring in data that is 2002. So what I'll do is I'll move this window forward in time to incorporate 2002. But when I do this, 1999 goes out of the window, right? So this is what is. So I need to decide like whether it is year wise or month wise or it is week wise or it is half yearly. So I need to define that, how much the sliding window moves forward in time, right, to incorporate new data and purge new data or purge oldest data. And this is what is there. So this is how it looks like. So alias information, status, volume metrics, and aging purging criteria. And then in the next lecture we are going to basically talk about the types of metadata. So there are different types of metadata. So there could be process data, right? There could be business metadata, or there could be technical metadata. So we'll talk about that, and then after that, in the third lecture in the module, I'll be talking about the design aspects of metadata. Right. So with this, I end this lecture. Thank you.